Okay, hello and welcome everyone. So here is a question that I get relatively frequently, which is why does the marginal revenue curve have the same intercept, vertical intercept, and twice the slope as inverse demand? Where does that come from? It's like for instance, if you have an inverse demand and it's like price is equal to 10 minus Q, how do you know that marginal revenue is 10 minus 2Q? Okay, well, so here's the picture we're looking at. We have price on the vertical axis, quantity on the horizontal axis. That's true of all graphs that we'll draw in economics. We'll always have our output or quantity on the horizontal. We'll have our price, some measure of price or value on the vertical. Here's our demand curve. And marginal revenue for a linear demand curve will always have the same vertical intercept and twice the slope, meaning the horizontal intercept for the marginal revenue curve corresponds to the midpoint of the demand curve. That's going to be the revenue maximizing point, and that's going to be the point where demand is unit elastic. So I've got some other videos talking about that. Here I want to just answer this question in particular. So let's just use the example that I started with. So suppose we have an inverse demand as price is equal to 10 minus Q. Let's take a notice of the vertical intercept, 10. It's right here. Take a notice of the slope. It's minus 1, so this has a slope of 1. Marginal revenue is going to have the same vertical intercept, twice the slope. If it has twice the slope, it's going to cross half as close to the origin. So if the horizontal intercept of the demand curve is 10, then the horizontal intercept of the marginal revenue curve is 5. Okay, so where is this coming from more specifically? Well, there's a calculus answer. So we define revenue as price times quantity. We have an expression for price, P is equal to 10 minus Q. Let's just replace that in this example. Marginal revenue is how revenue changes with changes in quantity. That's a derivative. So if we differentiate, if we take the derivative of total revenue with respect to output, we'll get marginal revenue. So first I'll write again, price times quantity, or 10 minus Q times Q. Let's distribute this Q, distributive property, so 10Q minus Q squared. And then let's take our derivative, it's going to be 10 minus 2Q. So if we were maximizing revenue, we'd set that equal to 0 and solve for Q is equal to 5. Though, just to answer my question, well, here was our inverse demand. It had a vertical intercept of 10. It had a slope of minus 1. My marginal revenue curve has a vertical intercept of 10 and a slope of 2, right? Where is this coming from? Well, it's this 2 here. It's from this Q squared. When we take the derivative, we'll always have 2 times whatever is the coefficient on quantity, right? And then here's a note just from before. If we want to maximize revenue, we'd set marginal revenue equal to 0. So we'd have 10 minus 2Q is equal to 0. We'd have 10 is equal to 2Q. The revenue maximizing quantity for the inverse demand, price is equal to 10 minus Q, is just a quantity of 5. That also corresponds to the midpoint of the demand curve. And then my last comment, this is the same as profit maximization. This is the same as profit maximization when costs are 0. So profit here, economists like to write pi for profit, otherwise we get confused with this p here. So pi of Q is profit as a function of quantity. Price times quantity minus cost times quantity. Let's replace this p with 10 minus Q, sorry about the messy, times Q, minus 0 for Q. If costs are 0, 0 times Q, that drops out. And then this is just revenue. So if our profit maximizing problem boils down to a revenue maximizing problem when costs are 0. So when would that happen? That sounds kind of unrealistic. It's actually not. So you could think of industries where marginal cost drop to 0 as being something that involves like information, something with tech. I mean, even like a non-tech example would be like the US Postal Service. So think of this as a natural monopoly where there's massive economies of scale. There's a large fixed cost associated with establishing the postal network. And then conditional on having this network in place, the marginal cost of delivering an additional piece of mail, it's near 0, right? That's the cost of the firm. What's the price paid by consumers? Well, it's whatever is the price of a stamp. Substantially higher than the marginal cost to deliver it. Why? Well, they're hoping through large volume to be able to recoup that large investment, the large cost associated with maintaining the network. Anyway, so there's an example where a near 0 marginal cost makes sense. Same thing with information goods as well. But anyway, yeah, so back to the original example. Yeah, so why does the marginal revenue curve have the same vertical intercept, but twice the slope as the inverse demand? It's this calculus thing, right? It's corresponding. It's it's a consequence of the fact that marginal revenue is coming from maximizing the revenue function, and revenue is maximized where marginal revenue is equal to 0. Okay, I'll go ahead and stop here. Sorry.